Way 96 deals with organic chemistry and talks about the homologous series. And the homologous series refers to table Q. All the homologous series is just a way of classifying different hydrocarbons, meaning they contain carbon and hydrogen, as single bonds between carbons, double bonds between carbons, or triple bonds between carbons. Now please note, if a if a compound only contains carbon and hydrogen, and it always contains single bonds between the carbon, it's going to end in a root word of ane, ane. So, for example, ethane is a contains only single bonds between carbon, and all alkanes, which is the word for single bonded carbon hydrocarbons, have this general formula: CnH2n plus 2, where n refers to the number of carbons. So, for example, if n equals 2, this will tell you how many hydrogens it should contain if all the carbon bonds are single. So notice if n is 2, then H is going to be 2 times 2 plus 2, which is 6. And notice this has 6 hydrogens. If the bond between two carbons contains a double bond, then it's going to end in the root word ene, or ene. It's going to have the general formula Cn2n. So for example, ethene has 2 carbons and 4 hydrogens in total. So here n equals 2. And these are generally referred to as alkenes. If the bond between carbons is a triple bond, it's going to contain the root word yne. So for example, ethyne contains 2 carbons, and it's going to have 2n minus 2 hydrogens. So notice when n equals 2, the number of hydrogens is also equal to 2. And these are referred to as alkynes. So once again, all alkanes have single bonds between carbons. All alkenes have double bonds between carbons. And all alkynes have at least a triple bond between the two carbons. In general, the formula is going to be Cn2n plus 2 for alkanes, Cn2n for alkenes, and alkynes are going to have CnH2n minus 2. And they're going to end in specific root words. Alkanes are going to end in ane, alkenes are going to end in ene, and alkynes are going to end in yne. And if you recall, the prefix ETH comes from the previous table in your reference table that specifies the number of carbons. So if we want to specify how many carbons are present, we would just simply change this prefix. So for example, methane contains 1 carbon, butane contains 4 carbon. If we have butene, it's still 4 carbons, but this time a double bond is present. If we're talking about butane, it has a triple bond present, and because of the prefix but, it's going to have 4 carbons. So I realize that was a lot, but hopefully when we apply this principle to Regents questions, it'll become more simple. So what is the chemical name for the compound CH3, CH2, CH2, CH3? The easiest way to do this problem is to count the total number of carbons, count the total number of hydrogens, and figure out which one of these answer choices would it have to be. Given that this compound contains 4 carbons in a row, we know that the prefix but refers to 4 carbons from table, which table is it? Table P. But refers to 4 carbons. So we can eliminate choices 3 and 4. Now, is this going to be butane or butene? In order to figure that out, we have to count the number of hydrogens. And we know that when we condense the formula into one simple molecular formula, it's C4H10, which has the general formula CnH2n plus 2. Here n is equal to 4. When we multiply by 2, we get 8, and add 2, we get 10. So in general, which homologous series does it fall under? It falls under the alkanes because it has 4 carbons, all with single bonds. And because it has 4 carbons, it has to be given the prefix but. So this is butane. Next question. There are several isomers of C6H14. The formulas and boiling points for 2 of these isomers are given in the table below. Identify the homologous series to which these isomers belong. So when it asks you to identify which homologous series each of these belong, it's going to fit in either the alkane, alkene, or alkyne category. And to determine which type of bonds are present between the carbons, we just need to look at the carbon-carbon bonds. And we see that, notice that all the bonds between carbon are all single. They're all single. Therefore, we would say it's categorized as an alkane. Notice you can figure out what type of compound this is. 1, 2, 3, 4, 5, 6 means that this is a hexane because it has 6 carbons connected in a row, and it has the root ane because they're all single bonds. Which compound is a member of the same homologous series as C3H8? Notice that this general formula follows the pattern Cn 2n plus 2, where n is equal to 3. When we multiply 2 by 3, we get 6, and then we add 2, we get 8. So in general, this is an alkane. Which one of these is also an alkane? Well, it should also follow this formula of Cn 2n plus 2. And when n equals 1, 2 times 1 is 2, and 2 plus 2 is 4, so CH4 is also an alkane. C4H8 has to be an alkene. C5H8 has to be an alkyne because it follows that formula. And C5H10 follows the alkene formula. So both C3H8 and CH4 are alkanes. They contain only single bonds. Which general formula represents the homologous series of hydrocarbons that includes the compound 1-heptine? Notice that the root word indicates the number of bonds present. So YNE means that it is a triple bond. And the ones that follow the general formula for a triple bond is Cn 2n minus 2. So choice 2 is correct. And you can verify this from table Q. A molecule of ethane and a molecule of ethene both have the same Well, in general, they must contain the same number of carbon atoms because they both have the same prefix. They both begin in ETH, eth, and eth refers to 2 carbon atoms. So, the number of carbon atoms has to be correct. The hydrogen atoms could not possibly be the same because ethane and ethene have different formulas. Identify the homologous series of hydrocarbons to which CH3CH2 belongs. When we condense the formula, we notice that there are 3 carbons, and how many total hydrogens there are? There's 3 here, 1 here, and 2 here, so 6. So our general formula is C3H6, and C3H6 follows the rule CnH2n, which means that this has to be an alkene. What type of alkene? Well, notice that there are 3 carbons present, so this would be propene. A double carbon-carbon bond is found in a molecule of Look at the root word to determine what type of carbon-carbon bond is present. Ane indicates single bonds, ene, double bonds, ine, triple bonds. Therefore, the answer has to be 2, pentene. Which hydrocarbon is a member of the alkane series? For something to be classified as an alkane, it can only have single carbon-carbon bonds. Therefore, answer choice 3 is correct. So in general, Alkanes are going to have the formula CN2N plus H2N plus 2. They're all going to end in ANE. Alkenes are going to have the general formula CnH2n and all going to end in the root word ENE. Alkynes are going to have the general formula CnH2n minus 2 and going to end in the root word YNE. Depending on the number of carbons present, we're going to use table P to indicate how many carbons are present. So for example, methane would have 1, ethane would have 2, propane 3, butane would have 4, pentane 5, etc. And we use this root word to identify what homologous series it belongs to, either alkanes, single bonds, alkenes, double bonds, or alkynes, triple bonds. I realize that was a lot, but hopefully it's a lot more simpler to understand now. Thank you for watching.